7 hours and 57 minutes into the PM of the 19th of September 2025. Wasn't sure I was going to get out and do any astro tonight. There are visible clouds floating by, but not high thins everywhere. So we may get some obscuration at times as we're looking at deep sky studies. My goal we're looking at Altair right now. I used it to synchronize the scope, and I'll have to synchronize it on the first other study we call up this evening, because accuracy of stellar coordinates is probably better for deep sky studies rather than stars, since they actually do move in space themselves. Anyway, what we're going to do is I'm going to start looking to the north and the east and try to pick out a few studies between 40 and possibly as high as 50 degrees north declination. That is my goal. By the way, we are looking right now at 0.5 second exposures and at 240x, which is 80% zoom. And the reason I selected 80% zoom is because that's 240x is what exhausts the resolution of the 150 millimeter Skywatcher ED refractor we are looking through. So I want to do a lot of views at 80% zoom tonight, and perhaps really spend some time on focus, but also how deep we can go, even though we will not be using 100% e-zoom, which employs all the pixels in the 3008 by 3008 pixel CCD imager in the ZWO Pro camera. Okay, I just switched from ASI image to ASI live. Live represents stacking, live stacking. And that will only occur when you see down here it says current stack, and we give a definition on the bottom. If it says no triangles, that means we're not actually stacking. This is actually quite a fine view of the stellar region around Altair. Once again, I'm going to push it up to our 80%. Our stars are a little bloated, but they're not too diffuse. So I think the focus is pretty good. I did expose the telescope earlier this evening, so it had a chance to cool off. And I left the focus locked in at what it was 2 nights ago when I was doing deep sky imaging. Of course, Altair is a first magnitude star, and that's what they look like when you're operating at a 10-second exposure time. Not a bad view of NGC 6888. It is one of the further north studies, although I do usually can pick it out. This is a 10-second exposure, and what I need to do is I need to recenter. So we're having a look at the 80% exposure time for maximum resolution at the central core of NGC 6888. What I need to do, however, is I need to do a recentering. So that's going to be something I'm going to do offline, and then I'll return to NGC 6888, and we'll have another view. Okay, I've recentered NGC 6888. Tracking looks pretty good. I'm getting lots of nice triangulations, and we are getting decent overlays, stacking. It says current image at the bottom. What I need to do now is reset my histogram. If I push it way over the right, the screen gets way too bright. Now that's the right histogram pointer. Here's a nice dark histogram, but we're losing just a little bit of luminosity in the nebulation itself. So I'm sliding it back to the left. And I think that's a pretty good look right there. Let's do that 80% zoom for maximum resolution. And here we have a look at NGC 6888. I have to tell you, I went through the entire 7500 to 7600 series, 100 studies in the NGC catalog. And guess what? There wasn't a single study. The only study that was there that was further north was plus 60 degrees, and that's way beyond my ability through the observatory to observe, to image. pen to the observatory would block it. Well, here we have, and I decided I was going to start with something on the equator and see where the scope points. So we're on the celestial equator. And by the way, Saturn will be there a little bit later on this evening. I will be doing some planetary imaging if the sky holds out, but I'll have to wait till after 10 o'clock. It is now 8:12 in the evening. This is supposedly going to be a view, and I think we can find some galaxies on the screen, of NGC 7401, a galaxy in Pisces, magnitude 15. Well, you know what that means. It's probably blue-violet, and it's probably magnitude 14.2 or something. It's an SA spiral, so yeah, about 14.2. 1 by 0.6 arc minutes, 231 million light years distant, means it's probably around 60,000 light years in diameter. I'm hoping it's centered in the screen. We are going to do our zoomage to see if we can pick the galaxy out. Wasn't readily apparent at the lower magnification. It's probably a little too faint for that low in the sky. Let's push it up to 100% e-zoom. There is a galaxy starting to appear right about here, but it could be a faint star. At 50% e-zoom, the stars start bloating out, as you can well see. Anyway, I'm going to allow it to do one more stack before I bail on this and tour through, using the Gemini 2 system, tour through the rest of the 7400 series to see if there's anything between 45 and 55 degrees north declination. What we're hoping to see here is NGC 7407. But you know what? I think the histogram probably is a bit off for seeing, that may be a slight improvement. However, there could be a bit of a tree blocking this view. But I am seeing hints of a galaxy right here. And the reason I selected this is we're heading north towards where we want to go. This is NGC 7407, a galaxy in Pegasus, magnitude 13.1. So yeah, it's quite visible on the screen, even though the scope's tilted at a fairly serious angle looking east. 13.1, 2 by 0.9 arc minutes. The aspect ratio plays out well there. It's a class lowercase c spiral, 291 million light years distant, puts this at about the size larger than Messier 31, maybe about 170,000 light years to 180 light years in diameter. We're at light ascension 22 hours, 53 minutes, 21 seconds, and 32 degrees, 07, 44. By the way, if Messier 31 were imaged at this distance, it would probably be about the same lightness, somewhere around magnitude 13.5, but I explored all that much earlier in my explorations of galaxies in terms of trying to quantify and make relationships. Let's go to our 240X. Here is our view of 13.1 magnitude NGC 7407. Here's our 60X 20% e-zoom view of NGC 7426, a galaxy in Lacerta. We're still heading north. We still got some aperture, a northern declination to continue. 7426, galaxy magnitude 12.3, 1.7 by 1.4 arc minute, elliptical, 242 million light years distant, puts it at about 120,000 light years in diameter. It's at right ascension 225603, declination plus 36 degrees, 21 minutes and 40 seconds. Let's do our standard zoomage to 150x. See if we can't make out the galaxy. And no, the stars are not looking particularly good now. I think we've lost our focus. I may have to refocus. Again, I'm going to leave it on this study to do so, but have to shift to ASI image in order to set focus. Okay, I centered once again on Alpheratz, and I tightened up the focus a little bit. You can see a little diffuse glow around the stars, but I do believe they look a little better. This is the 240x view that should resolve double stars, paired double stars down to 0.8 arc seconds if the sky and scope were in perfect order in terms of doing double star imaging, which I have not done, and I'm not sure how well it would work, but we will see later on tonight when I have a chance to image Saturn how much detail we can resolve. Okay, you can clearly see NGC 7426 in the field now. And the reason we didn't see it before is because the ZWO imager managed to rotate around during a maneuver, even though I thought I had tightened it down, mea culpa. Anyway, NGC 7426, a galaxy in Lacerta the Lizard, magnitude 12.3, but smallish, 1.4 by 1.7 by 1.4 arc-minute elliptical, 242 million light years distant, about 120,000 light years in diameter. We're heading north. Declination is plus 36 degrees, 21 minutes, 40 seconds, with a light ascension of 22 hours, 56 minutes, and 3 seconds. Let's see if we can go above 36 degrees in the 7400 to 7500 series. Okay, we've now pushed to 39 degrees above 36 to NGC 7445, Galaxy and Andromeda, faint, magnitude 15.6, 0.7 by 0.2 arc-minutes. Lenticular spiral, 229 million light years distant, probably 50,000 light years in diameter. I do not expect to see any hints of this 15.6, probably because it's a lenticular 14.6 magnitude galaxy on the screen. It is possible. Let's zoom in and see if we can pick it out. Oh yeah, there is a couple of galaxies right there, more edgy on, and then that's probably it here because it's 0.7 by 0.2 arc-minutes. I do believe we saw that before we started zooming in. Not bad. So here now we're pushing it up to 50%. It looks like there's a number of galaxies in this region, galaxy group. All right, so this is 150X, but what I'm trying to focus on tonight is 240X. Not bad on the stars. This is a brighter galaxy here. This is probably the faintest in the field. These two are roughly the same, although this one might be slightly fainter. So we see 1, 2, 3, 4 galaxies in Andromeda, and this field, which is probably, because it's 240X, no more than about 15 arc-minutes wide. Okay, compare this to the last one that we barely did a click on the mount, to NGC 7446, another galaxy in Andromeda, magnitude 15.7 elliptical. So this one would be about magnitude 14.3 because the delta between blue-violet and visual lights is about 1.5 magnitude, so 14.2. It's larger, as we can see it in the field, 0.8 by 0.8 arc-minutes, 242 million light years distant, right ascension 2259.28, plus 39 degrees, 4 minutes, 58 seconds. We're going to find something now in the 40 to 41 degree range. All right, my bad. I just saw this 16.7 magnitude, 0.3 by 0.2 arc-minute galaxy denoted just a pure spiral. And I just had to have a look. It's at right ascension 23 hours, 6 minutes, 9 seconds. Declination's about 6 degrees shy of where we want to be at this point. Plus 34 degrees, 4 minutes, 39 seconds. We are going to have to definitely do some zoomage on this. This is obviously not a magnitude 16.7 galaxy by whatever light it might have. This one right here may very well be our NGC 7486, denoted as spiral, very tiny. It's only bright because it's small. For instance, at 10-second exposure time, this star, for instance, is pretty bright and is probably about magnitude 16. We can probably go as far as 17.5 easily in 10-second exposures with the 6-inch refractor. But let me go a little deeper here. Here's our specified magnification of the evening, 240x, 80%, e-zoom, which exhausts all the resolution of a 6-inch refractor, and we're going to push it up to 100%, and we're starting to get very diffuse views. But yes, indeed, you can see how the star got brighter and the galaxy got dimmer with that surplus of magnification. So let's go ahead now. I really want to find something above 40 degrees that is not that's in the middle third of just entered the middle third of the sky. Kapla, going on for success. NGC 7618 is a galaxy. Remember, I had to skip now to 7600 because I had already done 7500 series. It's a galaxy in Andromeda, magnitude 13, 1.2 by 1 arc minute. Classic size for a 13 magnitude galaxy, which typically are about 1 arc minute by whatever arc minute, depending on the aspect ratio. It's an elliptical, 239 million light years distant, maybe 70,000 light years in diameter. Has a right ascension of 23,1947, but more importantly, a declination of plus 42 degrees, 51 minutes, 9 seconds. We are getting all of our aperture on it. First, we push 250x to get a view of a galaxy. It looks like it's got a bit of a tilt to it, an oblateness. And then we go to 80x, 80%, sorry, e-zoom. I do that often, 80x rather than 80 e-zoom. And we are getting our full resolution 240x vision of NGC 7618, 13th magnitude galaxy in Andromeda. Okay, maybe not too far north, but at least it's 40 degrees, 50 minutes, 42 seconds. NGC 7640, galaxy in Andromeda. I said Andromeda, which is probably the classic Greek way of saying it. Magnitude 11.3. So this is the brightest galaxy thus far and the largest. 10 by 1.9 arc minutes. A beautiful edge-on spiraling galaxy. As I said, magnitude 11.3. It's a spiral with a bar, but 2.5 times removed from lenticular. And because it's 11.3, we can assume that's the visual magnitude. 29 million light years distant, so quite close, about the size of our own galaxy, maybe 85 million thousand light years in diameter. We're at right ascension 232206, and I said plus 40 degrees, 15 minutes, and 42 seconds. It is worthy of some zoomage. Here we have it, and I'm going to play just a little bit. Oh, I think we're making out some spiral arms here. And see what we can do to enhance the texture in the galaxy. So I'm playing with the histogram sliders. You know, I think this one probably warrants a 30-second exposure. Why don't we do that? Okay, we now had 2 stacks of 30 seconds exposures on NGC 7640. I think it is bringing out some of the spiralicity. You can see a bit of an S-curve to the galaxy's spiral arms. Here's our 240x view. Not sharp enough for my tastes. We'll drop back to 150 and have a look at the galaxy. And then, you know what? We're getting pretty good stars. You know what that says? Let's try it at 60 seconds exposure. Okay, I have to admit it, mea culpa. For some reason, it was still on 10-second exposure when I claimed that it was on 30. This is the 30-second exposure of 11.3, 10 by 1.9 galaxy NGC 7640. Now that is what I expected to see, and I must have fooled myself into believing we were seeing more because epistemologically entangled myself with the notion we were seeing it at 30 seconds exposure, and we were not. So here we got a much clearer view. Let's do that 60-second exposure now. All right, we got 2 stacks now of 60-second exposures, which adds about 0.8 arc minutes, and I've calculated out 60 seconds to be the equivalent of roughly 103-inch scope at the eyepiece. Blows my mind. Whereas I believe something like 65, I don't have it memorized. I put the equation out before. I'll drop it in here again. This is our 2 stacks of 60-second exposures of NGC 7640, that galaxy in Andromeda, magnitude 11.3, with a nice 5-to-1 aspect ratio of magnitude of 10 by 1.9 arc minutes. There we go. There is our view of the evening, perhaps. All right, I've always been a sucker for planetary nebulae. Maybe it's because I'm advancing in my years. NGC 7662 is planetary nebula in Andromeda, magnitude 8.6, 17 by 14 arc seconds, with a magnitude 14 central star, 6,400 light years distant. Right ascension 23 hours, 25 minutes, 53 seconds, plus 42 degrees, 32 minutes, and 5 seconds. This is a 6-inch equivalent view of 0.2 seconds at 60x. And what we are going to do is push it first up to what usually gives the best view of stars, 50% e-zoom, 150x. Then we're going to push it up to highest resolution magnification, which is 240x or 80% e-zoom. And then we're going to push it up to 300x. And the reason I'm going to do that, and you can see the planetary right there, is I used to have a MK67 150 millimeter Maxitop. Really had fine optics, had a bit of a large obstruction, and I discovered that it was a superb instrument for viewing at high magnifications planetary nebula. So this is an example of brightish planetary nebula of small size with a lot of average surface brightness that you can make out through a 6-inch scope at higher magnifications. NGC 7662, magnitude 8.6, 17 by 14 arc seconds. That central star, which you probably can't see because we're operating at 6-inch, and 6-inch scope is only able to get down to about magnitude 13.5 under the best of conditions, is magnitude 14. 6,400 light years distant, puts it at about 3 times that of the Ring Nebula, much, much smaller. Right ascension 23 hours, 25 minutes, 53 seconds, and a declination of plus 42 degrees, 32 minutes, 5 seconds. We won't go out on this, however. I've got a couple minutes left. What we have here is NGC 7686, an open cluster in Andromeda. Magnitude 5.6, 15 arc minutes in size. Ooh, the stars are looking a little ugly. Let me stop for a second, and I'll give you the rest of the data. Oops. The brightest star in this cluster, NGC 7686, is magnitude 6.2. It's probably not even a member of the cluster, although it's possible. It's a class 1, which means I'm going to have to look that up because it's a 1 class 4. Well, I think the 4 is because the magnitudes of these stars are very diverse, and it's a class 1 should be highly condensed, and it's not. So I'll have to look that up, that rating system. 5,000 light years distant, right ascension 233007, plus 49 degrees, 8 minutes and 0 seconds. I think we're getting just probably about a 20% aperture block looking at the aperture of the scope. Okay, I thought we'd go out tonight on Messier 110. It's, of course, a satellite galaxy pretty close to Messier 31, but at this, even at 60x, we do not include anything of the great Andromeda galaxy in the field. I'm going to do a little zoomage on it. Here we have our 150x view. I can play with the histograms a little bit, make it more aesthetic, find the right balance between aesthetics and the view of texture. That's probably it right there. I can darken up the field a little bit with the right slider, and that is probably our best view right about there. Scope's kind of tilted. We're not getting any aperture block. We're at Messier 110's Galaxy in Andromeda, magnitude 8.1, 19.5 by 11.5 arc minutes, 3 million light years distant. Well, according to Gemini 2, it lies beyond the Messier 31 galaxy, which is about 2.5, and Messier 32 is about 2.4. Right ascension is 0 hours, 40 minutes, 22 seconds with a declination of plus 41 degrees, 41 minutes, 5 seconds. I would say that once you get into the Pegasus and the Andromeda galaxy series, there aren't many galaxies that are north of 45 degrees in declination, and Draco in Cassiopeia, and Cepheus. It just seems to turn out that way. There must be part of our Milky Way galaxy that is blocking all the galactic views that should be possible at those northerly declinations, some 22 degrees or 22 hours and later in the year. With that, I'm going to say Carpe Noctem.